All right, class, we'll be going over practice test 2, question 1. So the question asks, a car company claims that their super spiffy sedan averages 31 miles per gallon. You randomly select 8 super spiffies from local car dealerships and test their gas mileage under similar conditions. You get the following MPG scores: 30, 28, 32, 26, 33, 25, 28, 30. Is the actual gas mileage for these cars significantly different from 31? Use alpha level 0.05. Okay, so the first question is asking, what is the research hypothesis? Now in this case, we know, because the question asks, is there a difference? Once we hear that word, is there a difference, we know that it's going to be a two-tailed test, and our research and null hypothesis must reflect that two-tailed test. So in this case, the research hypothesis would be super spiffy sedans miles per gallon are significantly different than what the company claims. And then the null hypothesis would be super spiffy sedans miles per gallon are not significantly different than what the company claims. Okay, so that's the first two questions of this question. Third thing they ask is for T critical. Now, to get the critical T value of this question, you need to know the degrees of freedom, the tails, and the alpha level. Well, degrees of freedom is simply n minus 1. 8 minus 1 equals 7. Tails, we're looking for a difference, so there are two tails. And alpha is given, which is 0.05. If you go in your T table and you go to 0.05, two tails, down to degrees of freedom of 7, you will see that that corresponding value is 2.365, and the correct way to write that would be plus minus 2.365. All right. Next step is asking for the T obtained. Now, to get the T obtained from a raw data set, solving for a single sample t-test, the first step is you find the sum of squares. So in finding the sum of squares, I did it this way with the definitional formula. As you all know, you could use the computational formula as well. Use them both to check and make sure you get this first crucial step right so that everything else falls into place. So the first way to use the definitional formula is write down all your x's, get the sum of x. 232 divided by 8 is 29. Now we have that mean. All right, make sure you're getting the deviations from the sample mean, not the population mean that is given. So if you take all of these deviations, you get them right here, and then you square them, and you take the sums of the squared deviations from the mean, you will get 54. That is, your sum of squares is 54. Okay, step 2. Find the variance. The variance of a sample is the sum of squares divided by n minus 1, or the sum of squares divided by degrees of freedom. So 54 divided by 7 is 7.71. All right, next we need to find the standard error. That is simply the square root of the variance over n. A number of subjects in that sample, you get that number. Now to find T obtained, you take the sample mean, which is 29, minus the population mean, which is 31, divided by your standard error, which gives you a T obtained of negative 2.04. Now, is that going to be significant or not? Well, you have to compare this number, negative 2.04, to negative 2.365. Negative 2.365 is more extreme on the distribution than negative 2.04. Okay? It's a bigger number, right? Even though it's a negative, it's still a bigger, more extreme critical value. So you know that this is not a significant result, right? Another way to put it is getting 29 miles per gallon is not significantly different than the 31 miles per gallon that the company claims. So step 5, you want to get the R-square effect size. You simply square your T obtained value, and then that's over the squared obtained value plus the degrees of freedom. That will come out to 4.16 divided by 11.16, which equals 0.37. And we know that we have to fail to reject the null because it is not a significant result.